Greetings and welcome once again to my new calculus channel. My name is John Gabriel. So, uh, in the previous two videos, I talked again about this incredible method that I revealed to you. And so, in this video, I added an extra section to my article to explain the method. So, this is for the uneducated fools like math professors and teachers. Everybody else tends to get it. So, basically, the ingenuity of my method is that it allows one to find all the trig ratios using just this green line segment. Okay, so you don't have to know this circular arc here. And actually, uh, beauty, one of the advantages or beautiful parts of the identity or the formula is that it doesn't use anything but straight lines. So, for example, geometrically, it's very easy to construct a circle with an angle like this and then just join these 2 points so that you get this secant line. And then, of course, with a divider, you can find that and that. Okay. It turns out algebraically that this value here is actually square root 2 times the green line. Okay. And then, of course, from that, you can get all the other values as I'm about to explain to you now. So um, it doesn't use any advanced techniques like, infinite series, which is based on flawed concepts. And nobody after the ancient Greeks realized these things. And so I'm revealing it to you, but it's possible that the ancient Greeks knew about this. Okay, so, I mean, it's not recorded anywhere, but it would be very arrogant of me to say that they didn't know about it because it's based on their ideas and it's based on the use of a right angle concept, not a concept of degrees or radians. So you're not using degrees or radians, but I show you here how you can link the two. So in this diagram here, the magenta line is 1 minus x. The green line is just x. Therefore, the blue line, by simple right angle algebra, is the square root of 1 minus 2x plus x squared. And of course, the sign is simply the opposite over the hypotenuse, right? And as you can see, all these angles here, if you want to draw them. So, for example, let's get a pen here. So, it doesn't matter which particular uh, green line you choose to use. All these angles here are similar, right? This will always be similar to this and this to this and so on. So it doesn't matter where you draw that line. And another interesting thing is that all the triangles are isosceles. So let's just get rid of that. So that means that this side here will always be equal to this side here. Okay, it doesn't matter which triangle you have. So coming back to this, it's very easy, therefore, to see that the sign is this green line over the blue line. And of course, you can try it out using either the formula, or the actual division of taking the green line by the blue line. All right. So this method doesn't use degree or radian measure. It uses something that I introduced now, which is called radical unit measure. In other words, in terms of square root 2, it's nothing really remarkable. It's very simple geometry. And so you can follow this concept either in geometry without numbers or in algebra using the formulas I've just given to you. So, for example, the angle measure of 30 corresponds to 0.51764 radical units, or 0.5236 radian measure units, which is actually the length of the small arc that corresponds to this sine line. Okay, so it's generally not well known that the radian measure is true or immutable circular measure. Okay, now immutable means unchangeable, and sometimes I forget the meaning of that word. Am I right in saying that it's unchangeable? Let's look that up. Immutable Uh, so immutable, yeah, unchanging. So I had the right idea there. Sometimes I have to check up on myself. My memory is not that good anymore. So uh, radical measure is just what I explained to you. On the other hand, degree measure is arbitrary, and it's not generally true that a circle needs to have 360 degrees. It can have any number of degrees that you like. Now, 360 degrees is simply a convention that was carried over from the Babylonians. Of course, the Greeks didn't adhere to anything before or after them. They discovered all these things systematically, validly, and accurately, unlike the morons of the last 400 years, the mainstream morons, who dare in their ignorance to criticize what the ancient Greeks did. In fact, the ancient Greeks were so much more advanced that in reality, mathematics hasn't really gone anywhere. There isn't such a thing as an irrational number or a real number. And by the way, the Greeks knew that there were ratios that couldn't be measured, and it didn't flummox them, it didn't shock them. Nobody committed suicide when they discovered that the diagonal of a square has no measure. They were not surprised at all. They expected it. They were brilliant beyond any little dimwit belief of the high priests of the Church of Academia. So, for example, you won't get a little lady boy like that stupid creep Marcus Cliver from Sweden, or that vile Jew reptile Jean-Pierre Massager, who floats around on Psi.math, or any of those other fools. I'm not going to mention their names. Um, Needless to say, idiots like Gilbert Strang and Jack Hazinger, who don't even know most of these facts. But having said all that, I've revealed this to you. So if you're not already a subscriber, become one. This is the last video on this topic. Um, I shall not be revealing anything else. As I said, if you want to learn more, you need to contribute at my GoFundMe page. Once it reaches 500,000, I'll reveal a lot more to you. If it doesn't reach 500,000, there is a lot you'll never get to know, and it'll die with me. So become a follower on Academia. This is my Academia profile. And I'll place links to all the other necessary GoFundMe page and the article. I'm John Gabriel. This is New Calculus Channel. Till next time, goodbye.